Good day everyone, my name is Wong and today I'll present about my research project with the title of Effect of Nanoparticle in the Castor Oil on the wax deposition of Malaysian crude oil. So let's get started. The contents of this presentation will include the introduction, literature review, methodology, results and discussion, conclusion and finally references. For the introduction of this project, one of the most common problems in the pipeline transporting crude oil and during the production during stream is wax deposition. The wax or paraffin deposition will cause pipe blockage as shown in Figure 1. Due to the high maintenance cost of addressing this wax deposition and the safety concern, the cheap chemical emitters are developed to help the industry to halt the financial losses. So many chemical emitters can actually help to prevent wax deposition. However, some of it are very limited and expensive to obtain. Problem of wax deposition will continue to occur if the oil production demand for wax crude oil is there. The combination of castor oil and nanoparticle have not been studied before. So the objective of this study is to evaluate the performance of castor oil with and without the incorporation of sodium chloride nanoparticle to solve the wax deposition problem for Malaysian crude oil through a co-vinkle study. The scopes of this study are screening of the best concentration of sodium chloride nanoparticle, the best concentration of castor oil, and the best concentration of castor oil together with the best concentration obtained in A. So the comparison of the wax inhibition performance with the best wax inhibitors obtained in A, B, and C, and the different co-vinkle temperature was also studied. So the calculation of the PRE for all the inhibitors of different concentration to test to determine their performance toward the inhibition of the wax formation. For the literature review of the project, there are many strategies to handle wax deposition. However, chemical methods or chemical emitters are becoming more prevalent compared to the thermal and mechanical methods. This is because the chemical methods are more effective and economical. Also, nanotechnology or nanoparticles have been developed or contributed in this performance of enhancing the wax inhibitors. So natural surfactants such as vegetable oil have been investigated to be much more promising than the conventional surfactants in wax inhibition. So these are some of the previous experimental works that are related to the wax inhibition study. So the first one would be by Dr. NORIDA, which she used the nanoparticle sodium chloride nanoparticle together with the poly-EVA and poly-MA. That the findings from it was the viscosity of crude oil reduced with the addition of inhibitors and further reduced by addition of the nanoparticle. The third one and fourth one would be from Akinemi, which we was using the castor seed oil and other vegetable oil as the wax inhibitor. So the plant seed oils shows that it depressed the poor point samples more than TEA, which is another chemical inhibitor used commonly, which the vegetable oil shows a better result. So the vegetable oil were capable of decreasing the wax deposition tendency of the sample. The methodology of this experiment, the materials used are sodium chloride nanoparticle and castor oil as the wax inhibitor, and N-heptane and cyclohexane as the wax content study. So the flowchart of the experiment are the crude oil sample was obtained and it was characterized by the apparent gravity, wax apparent temperature, WAT, proper temperature, wax content, and viscosity. And the wax inhibitor were prepared from the castor oil and the sodium chloride nanoparticle solution. So by screening the best concentration and calculating the paraffin inhibition efficiency, we can study the effect of different co-vinkle temperature and finally calculate the paraffin inhibition efficiency also. So the results obtained, the characteristic of crude oil sample are shown in this table, and we can see that the blank crude oil deposited waxes on the cold finger or U-tube as shown in figure 2. For the effect of inhibitor concentration of wax deposition using different types of wax inhibitor, from figure 3 we can see that the wax deposition and PIE calculated of different concentration of sodium chloride nanoparticle. 200 ppm of sodium chloride nanoparticle had lowest wax deposition and also highest PIE. So with the reduction in aspartate aggregation by the nanoparticle, wax crystallization and deposition could be hindered by this nanoparticle. For different concentration of castor oil, from figure 4 we can see that when the concentration of CO decrease, the wax deposition or PIE increase, and 0.83 volume percent of castor oil as a wax inhibitor had the lowest wax deposition and highest PIE at 29.6%. This is probably due to the ricinoic acid molecules of castor oil present a great interaction with the hydroxide molecule, thereby increase the inhibition of the wax deposition. The effect of addition of sodium chloride nanoparticle, which is 200 ppm obtained before, so to the different concentration of castor oil. So from figure 5, we can see that the lowest wax deposition is using the 7.5 milliliter of castor oil together with 200 ppm of sodium chloride nanoparticle. So the volume of CO used is actually higher than the sole castor oil wax inhibitor. So this is probably due to the cyclohexane present in the nanoparticle, which affected the ricinoic acid as the wax inhibitor. For different cold finger temperature using the best concentration that obtained before, so according to figure 6, the wax deposition will increase when the cold finger temperature decrease for crude oil with or without the chemical inhibitor. So according to Fick's max law diffusion, the low temperature causes radial temperature gradient and the concentration gradient increase, resulting in higher wax deposition. From figure 7 shows that sole 200 ppm sodium chloride nanoparticle has a relatively higher PIE than other chemical inhibitor, so it was the best chemical inhibitor in the study. As a conclusion, both castor oil and sodium chloride nanoparticle in crude oil had lower wax deposition than crude oil. The order of performance of the wax inhibition by different wax inhibitor are 200 ppm sole sodium chloride nanoparticle, followed by 200 ml of sole castor oil, and finally the 7.5 ml castor oil together with 200 ppm of sodium nanoparticle. When the wax deposition increased, cold finger temperature decreased. And these are the references used in this study. That's all from me. Thank you.